Hello everyone, my name is Temmuz. I'm a third-year molecular biology and genetics student in Bilkent University. Today I will present you my Physics 102 laboratory final project. So basically my project aims to verify the Kirchhoff's junction rule, which indicates the conservation of the electrical charges within a steady-state direct current circuits. Before looking at the setups, let's explain the core physics principle behind this experiment. Derived directly from the law of conservation of charge, this rule states that the algebraic sum of all currents intersecting at any single node must equal exactly zero. To test the theory, I used a variable DC power supply, connecting cables, a digital multimeter set to DC voltmeter mode, and finally identical 100 ohm resistors. I constructed two distinct configurations using these components. The first setup is purely parallel network where the current splits into two branches. The second setup is a series parallel combination circuit where the total current passes through a series resistor before distributing into parallel subnetwork. During the procedure, I systematically adjusted the independent source voltage in uniform increments of 2 volts, moving from 2 volts up to the maximum of 8 volts. At each specific voltage step, I allowed the circuit components to thermally stabilize for 20 seconds to ensure steady-state conditions. I then individually recorded the resulting current values from all 3 branches. To minimize random errors, I performed 3 independent trials for each voltage configuration and calculated their averages. Let's look at the results. I plotted the currents against the source voltage to evaluate our data using linear regression. As you can see in figure 1, for our parallel setup, the theoretical slope for the total entering current was exactly 20 mA per volt, while our experimental junction sum yielded a slope of 20.4 mA per volt. This shows an excellent linear agreement with an incredibly low error rate of just about 2%. Looking at figure 2 for the combination setup, the alignment is even more precise. The series branch current slope was 6.66 mA per volt, matching the experimental parallel sum slope of 6.65 mA per volt, almost perfectly with an error rate of less than 0.2%. Even though I had almost perfectly matching results from the experiment to the expected values, I had still some error rates even though they are very low. And these errors can be accounted for the internal resistance of the multimeter I used and the tolerances of manufacturers of the resistors. So looking to the results we had, the experiment successfully proves the Kirchhoff's law. Charge is perfectly conserved and neither gained or lost at any junction. Thank you for listening.